Hello to the brownies from Girl Guiding Ulster. It's Alita here from Science Starz, and I'm delighted to be doing some hands-on activities with you today. Today we're going to become engineers. Now, you might be wondering, what is an engineer? What does an engineer do? You've probably heard the word before, but you may not know exactly what an engineer does. So what an engineer does is that they basically design and build something that's going to solve a problem. Or they might develop something that improves upon something that already exists. So for example, telephones. Telephones have changed so much over the last few decades, from being ones that you had to dial the number, turning a little rotary dial in a circle, and these would have all been connected to the wall, to now what we have today, which are mobile phones that you just punch the button in your hand. You can be anywhere at all and you can make a phone call. So engineers would have been involved in that process. So there are so many types of engineers. You can have electrical engineers, chemical engineers, mechanical engineers. So today we're going to do a type of activity that involves building something. We're going to be building a catapult, and then I'm going to be talking about how this activity can relate to the real world, and I'm going to introduce you to a business in Ulster that does something similar. So let's get started. You may have seen a catapult in a museum or in a film that takes place in medieval times. Catapults were mainly used as a military weapon in ancient times to take down castle walls, or pirates used them during the 17th century. Now, a catapult is a type of machine used to forcefully propel stones or other projectiles into the air, and the path these projectiles take make an arc and land on whatever target happens to be wherever the projectile lands. Once that projectile is launched, gravity comes into play and that projectile eventually falls to the ground. You will need 7 craft sticks or lolly sticks, a spoon of some sort. Here you see a variety of different spoons you could use. You will need 6 elastic or rubber bands and some things to launch. It can be pom-poms or ping pong balls or anything lightweight, nothing too heavy, as we do not want to injure anyone. So the first step is to take 5 of your craft sticks and stack them all one on top of the other, like so. And what we're going to do is we are going to secure these sticks together by wrapping the rubber bands around both ends of the stack. So wrap it around as tightly as you can, and then take another elastic and wrap it around the other end, like so. For this next step, you're going to take the 2 remaining craft sticks and an elastic and wrap it around one end of the craft sticks to secure them together. You should be able to carefully open one end of the craft sticks, kind of like a crocodile's mouth. So once you have it open, grab the lolly sticks that you stacked and put it into the mouth of the 2 sticks, as tightly or as close to the end as you can. Careful not to snap the sticks. Now we're going to secure the 2 stacks of sticks together, wrapping the elastic diagonally. So if you can see what I'm doing there, I'm wrapping diagonally and then I'm doing diagonally the other way. so it looks like an X. Once you have that done, just make sure that it's nice and secure. And this is going to be our launcher. Now we need something to hold our projectile or our missile, the pom-pom or the ping pong ball. So what we're going to do, we're going to take our spoon, and if you can lift up a few of the elastics, slide the base of the spoon underneath the elastics. If you can't get it under, don't worry, we'll come back to that. So next, we want to attach the spoon at the top. So take another elastic and wrap it around as many times as you can at the top to secure the lolly stick or the craft stick to the top bit of the spoon. So very carefully, just keep wrapping it around until it's tight enough that it's secure. So now what I want to do is I want to secure the bottom bit some more. So I'm going to take one more elastic, and I am going to basically do what I did when I was connecting the two stacks of sticks together. So I'm going to do it diagonally again, wrap the elastic around, and then I'm going to twist it around and do it diagonally the opposite way, so it ends up looking like an X. It can be a wee bit tricky. Don't worry about it being an exact X. Just wrap it around in any way that is going to make it nice and secure. So that is our catapult. When you bend the spoon back, you add energy to it because you are stretching the elastic, and an elastic can store potential energy if it's stretched. So this energy is stored in this launching device. So you're basically loading up your spoon with energy. When you let go, this stored energy is released and converted into energy of motion and shoots whatever is on that spoon through the air. So it's time to try your catapult out. Why not find something around your house, such as lids or some cups or anything that you could use as a target, and see if you can land your projectiles into your cups or lids, or if you can hit your targets. What are you using? What happened to your projectile when you tried it out? Did it fly? Did it go high or low? Where did it land? And what do you think would happen if you pushed the spoon further down? Would it make it fly higher, further, both higher and further, or take the same path but maybe faster? The most common use of catapults today is to launch certain planes into the air. If a plane's runway is not long enough for the plane to accelerate or go quickly enough to take off, such as on an aircraft carrier, a catapult is used to propel or launch the aircraft into the air. There is a company called RLC in Newton Abbey, and it is an engineering manufacturer that builds things such as plane ejection seats. And an engineer at RLC would be very interested in projectile motion, which is the same type of motion that takes place with a catapult. The path it takes would be very important to an engineer, and they can study how fast or how far an ejector seat would go based on the size and weight of it, and how strong the potential or stored energy is prior to ejection. So what you're seeing here today with your catapult is very relevant to the real world. To all the brownies from Girl Guiding Ulster, I hope you've enjoyed making a catapult today. I hope you're able to hit all your targets, and I look forward to seeing you in the next video. Bye for now.